One subject that often confuses people is whether to do a one-way or a two-way hypothesis test. In other words, when we're counting extreme results in a resampling test, do we count extreme results in both directions or just in one direction? Consider the hypothetical survival rates of a new drug, call it A, compared to standard therapy. And let's say that the experiment that we did showed that A had higher survival rates compared to the standard therapy. Now, if A had not had higher survival rates, if A did worse, what would we do? Well, we wouldn't even go beyond the experiment to a hypothesis test. We would probably discontinue research on drug A or go down some different avenue. But we're not going to be doing statistical analysis of it because it showed right away that it wasn't effective. The purpose of a hypothesis test really comes in when A does do better in the experiment, but we want to know, could we be fooled by chance sample results into thinking that that effect is for real? So we want to know whether the superior performance of A might be the result of chance. So we're going to count sample differences that are extreme only in one direction. If it had come out in reverse, that standard therapy did better than A, we wouldn't, as I say, be going to a hypothesis test. So the protection we need against fooling ourselves is only taking effect in the case where A outperforms B, in essence, on one side of the spectrum. Consider another case where we have two established therapies, A and B, both already in use. And you do an experiment to see which one does better. And whichever one does do better will get more use by health agencies. So in this case, it doesn't matter which one does better. We're going to go forward with that recommendation. If A does better, we're going to go with A. If B does better, we're going to go with B. But we have to establish first that its margin of superiority is more extreme than what we could arrive at by chance. In that case, we have the possibility of being fooled in either direction, either in favor of A or in favor of B, because we're interested in and would act on either outcome, in contrast to the first case where we would only act on the outcome if A was superior. So in deciding whether to do a one-way or a two-way hypothesis test, you need to be guided by the original situation and whether you're looking for an effect in one direction or whether you would be interested in an effect in both directions. That governs whether you need the protection against chance in one direction only or in both directions.